So in your notes, correct me if I'm wrong, there was also calculator directions. Is that a part of the notes? Yes. Okay, so I highly recommend that you print this off if you did not. If you can't find it, let me know. I can look after class, but I'm assuming some of y'all got, okay, it's there. All right, what we're gonna be doing is this right here. We're going to create tables. So we're going to be going through these steps. So if you will look at your notes. Those same directions are in your notes right here. Now, before we go and do all this and apply it to a problem, I want to introduce and show you how to do this, okay? So hang on, I want to clear everything out. Okay, so we have been in 1.1, we were given, say, a function n at t, and it might say 2 times t plus 3. Right? If we looked at that in a table, what always goes first? Variable or function? Variable. What letter is my variable? T. Here's your variable. Here's your function. So let's say I let t be 0. So if we calculated that, it would be n at 0 equals 2 times 0 plus 3, and my output would be 3, right? Let's say I put in a 1. 2 times 1 is 2 plus 3 is 5. Right? That's how that all works. Okay, well now we're going to learn how to enter this equation into the calculator. But here's the thing. In chapter 1, sometimes we had n at t, sometimes we had q at w. I mean, all different letters were used. Okay, and so we're not going to use all of those letters in our calculator. So in your calculator, the function, so when we go to put it in the calculator, your function is always y, and your variable is always x. So what that would mean is, this is my function, so that's going to be my y. My variable t is going to be x. So we're going to learn how to put this into our calculator. Okay? All right, so look at your first bullet point. In your notes, it says press y equals. Here's y equals. We're going to press that. So y1 just means y, that's an equation. The sub 1 means your first equation. If you needed to put in a second equation, you could do it on y2. It just means you have 2 equations in there. Okay? All right, so the equation we're going to put in is 2x. So push your number 2. And then, if you will look, you'll see this button that is to the right of alpha. It has x, t, theta, and n. When you press that, that automatically puts an x in there. And then we're going to do plus 3. Okay? Now, if you look at your second bullet point, it says enter the entire equation. We just did. It says don't forget parentheses if you need them. The second one we do, I'm going to add parentheses, so I'll show you how that works. Okay, now what we're going to do in the next bullet point, it says set up the table. All right, to set up the table, we're going to press second window. All right, so you have to push the blue button second, and then above window in blue, it says table set. So it's second table set. And you're going to get this. And this TBL means table start. Where are we starting on our table? The number 0. And then you can push enter or down arrow. Change in table means what are you going to count by? Are you going to count by ones? So like I went 0, 1, so I'm going by ones. So I'm going to put a 1 in there. You, depending on the problem, you might go by 2s or by 5s. That'll make more sense in a little bit, okay? But what this means is my table will start at 0 and then it'll go by 1s. So for the X value or the variable, we'll see 0, 1, 2, 3, 4, 5, 6, 7, like a count, running counting, okay? All right, so then the next bullet point says press second and then graph, because if you'll see in blue above this button, it says table. There's my table. So where the 0 is, if you look to the right, there's where that 3 is. 1, they put in 1 into the equation and we got 5. Then they put in 2, so I'm going to go ahead and fill in 2. It gave me 7, and 3, it gave me 9, and then etc. Okay, so it creates the table for you. All right, so before I go to the next equation, because I had a few in my first class that are like, I didn't get that. So do I have any questions? Okay, if you're not wanting to speak up, but you do have questions, ask me after class. Okay, all right, we're just going to leave that in there for right now. All right, so do second quit. So that equation is still in there. Okay, all right, now I'm going to do a second equation. Let's say we had U at W equals -1/3, open parentheses, W plus 1. All right, so in my table, what's my variable? W. What's my function? U. But for purposes of our calculator, what do we call the function? Y. It's always your Y. Your variable is always your X. So I'm going to rewrite this as Y equals -1/3 parentheses X plus 1. Okay. All right, this time I'm not going to start at 0 because we don't always start at 0. I'm going to start at 9, and I'm going to go by 3s. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. All right, so what button do I push to enter my equation? Y equals. All right, now, if you want to clear out that first one, we'll do that in a little bit, you can, but here's what I wanted to show you. You don't have to. So you can down arrow, and this Y2 means I'm putting in a second equation, okay? All right, so I want to put in negative, so be sure you push the negative button, not the minus button. And then I need a fraction. Well, we know that from unit 1, that is alpha Y equal 1. And in the numerator, I put 1, and then I down arrow and I put 3. And then I right arrow. And your open parentheses is above the number 8. And then the X button plus 1, and then your closed parentheses is above the number 9. Okay. All right. Now I need a different starting point and change in table. All right, so this is second table set. And we're going to start at 9. And the change in table is every third number. And now I'm going to do second table, and it creates the table for me. Now, pay attention. It took away the starting at 0 that we did for the first equation, but that first equation is still in there. So I'm looking for, to complete my table, my second equation. So this would be -3.3 repeating, -4.3 repeating, -5.3 repeating, -6.3 repeating, and then depending on what you do, you'd fill that in. Okay. All right. Any questions? All right, I want you to go to y equals, and I want you to clear out those equations. All right, so now we're gonna actually apply that to problems that we've encountered, but we're gonna also put the equations in. Okay, so what do we have going on here? Circumstances surrounding the George Deer Reserve in Michigan have made it particularly easy for ecologists to monitor accurately the growth of deer population on the reserve to develop a logistic growth formula for the number. All right, here's my function stuff of deer expected to be present after T years. Okay, so not any different. We want to define what our function is, and we want to define what our variable is. Now, this particular problem is quite wordy. So I know sometimes somebody would be reading this and go, oh my gosh, where do I find it? Well, to me, the easiest thing to find is the variable after T years, right? And I can look here and go, oh, N is my function, T is my variable. So my variable is T, and that is years. So that means my function has to be N. So we've got to figure out what N is, or the function. Well, what are they measuring with this equation? Number of deer, or deer population. So you could write deer population, or you could put number of deer. All right. Now, in the past, if you were given like N at 8, you would do alpha y equals 1. You'd put this in the numerator, and then in place of that T, you would put 8 and hit enter. That's how we did it in chapter 1. But now what we're going to do is we're going to put this equation into our calculator. So what do we put in place of the N? 1. That's your y. We're going to rewrite the equation as y equals, it's still 6.21 over 0.035 plus 0.45, but raised to the x. All right, so this is what you're going to enter into your calculator. So let's go ahead and do that. All right, so we cleared out all the equations, and I'm on y equals. So I already have my y. I need a fraction, so that's the same as we did before. Alpha y equals 1. In the numerator, we have 6.21. Down arrow to the denominator. And then you can put 0.035. You don't have to put that first 0. It's up to you. 0.035 plus 0.45 up arrow x. Now, I would recommend, before you would go on and do the next step, double check that you entered it correctly. I had one student that was like, Ms. Schamberg, I'm not getting what you are. I went back to her equation. She had 0.35. She left out the 0 accidentally. And then, and I do this sometimes, she had plus 0.54. She switched those two numbers. So double check that you have the correct equations. Okay, I'm going to put that up here because I don't know yet what to do on my next step. All right, so look at part A. Use the graphing calculator to make a table. All right, I'm going to go ahead and do a horizontal table. What always goes on top? Variable, which is T, which is years. Function is N, which is number of deer. And then I'm like, okay, variable in my calculator is the X. Y in the calculator is my function. All right, so use a graphing calculator to make a table showing the number of deer present after, and then they tell me what numbers to use. So we're doing a table where we have 0, 4, 8, 12, and 16. Okay, all right, so here are your calculator steps. 1, y equals, and we've already done that step. We pushed y equal, we already put this equation in there. So we've done that, okay? All right, your second step is to access the table set button. All right, that is your second table set. Second in blue, and it's this window button. And this is where it's going to want you to put in a value for your starting number. Well, this problem told me to start with what? 0. So I'm going to put in 0. And 0, 4, 8, 12, 16. Then your change in your table is going by what? 4s. So on table or change a table, I'm going to put in 4. And then your last step is to get to the table, which is your second, the last gray button. So if I come back to my table when X is 0, so when we started, we had 6 deer. 4 years later, we have 81.704 deer. Okay. They're populating themselves, aren't they? Then on year 8, wow, 169.3 deer. Year 12, 177.08. Year 16, 177.41 deer. Okay, now it's going to give you a whole lot more than that, but that's all that they told me to do on the table. So I'm going to stop there. Okay, now we know from unit 1, I can look at the table and see what's going on with the population of the deer. What's happening with the deer? They are increasing, right? These numbers get bigger. So we know that the deer population is increasing at a, what happens here at the end? Decreasing rate. It starts slowing down. Okay. All right. Part B. Find in at 8 and explain. Okay. In at 8. So I'm going to go to my table. 8 years. We have 169.3 deer. Be sure that you label deer. Don't just give me a number. All right. So we read that from the table. Now we're going to go to the explain, which we just verbally did that, right? Well, no, we did that for the table in general. This wants to know for this statement right here. Some of you all still need to practice this. Okay. Again, I'm just going to rewrite this in words. So I start out and I go, well, what is in? Oh, that's the number of deer. So if you said the number of deer, if you said the deer population, either is fine. The number of deer what does 8 mean? After 8 years. Now, if I knew it was since 2000, I would say in 2008, but we don't know that. So I'll just say after 8 years. Equals is the word is. Now, if you wrote 169.3, I would give you full credit, but let's be honest, we can't have 0.3 of the deer, right? That might be kind of sad. So I'm just going to say is 169. And if you wrote deer again, that's fine. Just since you said the number of deer, you wouldn't have to. And then don't forget that freaking period. Yes, I actually had to take off a little bit on some people for not giving me the period. Okay. All right. Explain how the population varies with time. Include your explanation using the average rate of change. Okay, I had a few people that left the ARC question blank. Guess what? It doesn't go away. We still are going to do this, so you need to learn how to do it. From 0 to 4 year, and then the average rate of change 8 to 12 years. Okay, all right, so the first one, average rate of change 0 to 4. All right, I'm going to come up here in my table, 0 to 4. So we're looking at these values right here. And remember, it's the change in function, and you always go backwards over the change in the variable, and you always go backwards. I still had a few that put the variable on top on this. So we would do 81.704 minus 6 over 4 minus 0. All right. Go ahead and clear this. No, sorry, don't clear. It didn't do anything. Do second quit, and that stuff's still all in there. So we can come back to it. Okay. All right. So I'm going to do alpha y equals 1. And we had 81.704 minus 6 over 4 minus 0. When I hit enter, it's already putting this over 1. Okay, so we have 18.926 over 1, but you have to tell me what each of these is. So 18.926 is your function, which is your number of what? Deer. So 18.926 is deer per 1 what? Year. All right, so that tells me from years 0 to 1, it increased almost 19 more deer. And then from 1 to 2 years, another 19 deer, and so forth. Okay, so that's what's going on from 0 to 4. Now it wants us to do the same thing from 8 to 12. So now I'm going to come up and I'm going to look at 8 to 12 because it could have a different rate of change. Again, it is the change in function over the change in variable. So 177.08 minus 169.3 over 12 minus 8. Clear that out. Alpha y equals 1. No, my numbers 177.08 minus 169.3 over 12 minus 8. Oh, I did something wrong. Oh, look, I don't have a decimal point in the 177 because I was like, that is not right. 0.08. All right, is that more like what you guys got?
Yeah.
Okay. So 1.945 deer per 1 year. All right, now we were able to determine what was going on just by looking at the table, right? You told me that the deer population was increasing at a decreasing rate, and that would be the explain. This also tells us that since both of these numbers are positive, then we know that the population is increasing. But look how many per year were occurring from years 0 to 4, and look at how many more deer you were increasing per year from 8 to 12. It definitely slowed down, which means it has a decreasing rate. Okay, so this says explain. So we showed our two average rated changes. So when we explain the number of deer or the deer population, whichever way you want to write it, is increasing at what kind of a rate? I don't want to know each specifically. I want to know over. This tells me that the rate is, so this was the rate from 0 to 4. This is the rate from 8 to 12. So was it slowing down, decreasing, or was it speeding up, increasing? Which one? Decreasing. So it's at a decreasing rate. Period. All right, part D is on the next page. All right. I want you to do second table and get back to the table. Okay. All right. D says find the carrying capacity for the deer reserve. What does this mean? What is it asking for? Which is, you are correct, the limiting value. Now you can see it in the table you made on the other page, but this even allows me to see further because we were at 177.41 and then notice it goes 177.43, 177.43 and so forth. So what is the carrying capacity or the limit of the number of deer? 177 deer. Now, there is one more question, but that'll be a good kind of review again, because we've just started learning this. So on Monday, we'll start there just so we can be sure we know where we're at. So we're going to stop here and we'll pick up there. Okay. All right. So technically, we have not completed 2.1 yet.